This semester, our Iowa State Manufacturing and Industrial Systems Engineering capstone team worked closely with a large manufacturer of a product with a refrigeration process. The team is comprised of Connor Eric, Brendan Johnson, Joshua LaCour, and Austin Polk. Due to the sensitivity of the project, the company name and some relevant data will be omitted. This project was centered on their main production line, which is expected to see an increase in demand of 45% by 2020. This product line assembles many components that produce over 850 units a day, and it needs to increase this throughput by 63% to meet future demand. The driving factor for this project is that the assembly line is currently not equipped to meet the need for an increase in the throughput rate. The bottleneck inhibiting the throughput increase is the 20-minute plumbing evacuation process that ensures all units are free of contaminants before further moving down the assembly line. The objectives of this project are to reduce the cycle time of the unit evacuation process through a redesigned layout and a re-engineered gantry system. Also, to increase the likelihood that units reach quality specifications during the evacuation process. And to ensure all assembly stations on the line reflect balanced work with the newly implemented system.
During the current state analysis, we utilized observed time studies, a design of experiment study, and a quality data analysis. From these findings, we created a redesigned AutoCAD layout and a re-engineered gantry system. From our observed time studies, we identified 4 stations on the line that are not meeting the takt time required to meet future demand. From this information, we suggested a rebalancing of the line. Our recommendations included creating 1 new station, moving 2 different tasks from their current station to a different station, and removing 1 task altogether. With these recommendations, all stations meet the future takt time.
After rebalancing the condensing line, we performed a design of experiment study on the vacuum drawdown process. We concluded that it takes 15 minutes for a unit to be drawn down to 200 microns. After analyzing the current state, we analyzed a future state design with a new pump. This test concluded that it is 83% faster to draw down with this new pump and manifold system, going from 15 minutes drawdown to 2.5 minutes.
After the design of experiments, we performed a process capability analysis with the company's quality data and found that their process was not capable. 63% of units are currently being overdrawn below the lower control specification limit. We then created a way to reduce the variation of the process. A new process flow was developed so units would be able to flow to the next station after the vacuum process was completed. This method also saved the company 94 square feet compared to the current floor space. The new system we created to replace the gantry system utilized stalls. Units would be individually drawn down by being connected to a single pump rather than 4 units per 1 pump, which can create problems with quality if a single unit has a leak.
Based on these recommendations, we developed a budget that calculated the initial investment needed for this project as well as the potential cost savings. With this information, we were able to calculate the net present value and return on investment for the project. With the project completed, we gave our final recommendations to the client with hopes that the project gets approved and implemented.